This is TMUA Question of the Day, Day 2 Hints with StopMaths.com and Tobin Payne. So our first question, which is our A-Level Plus question based on combinatorics. Remember, combinatorics is a big part of the stats course for A-Level Maths. And one of the things you always want to ask are there any constraints? And there will be constraints, of course, for any TMUA question. And here the constraints are that the dictionaries need to be kept together and the novels need to be kept together. The other thing to ask is, are the novels unique as novels? And here they are. So we're not looking at combinations on its own. We're actually looking at permutations. So you can imagine we've got three novels and the order of those novels matters. Now, if there were no constraints at all, we would just have 5 factorial ways of organizing 5 objects, which is 120. Now, there are some constraints, so it has to be fewer than that. We can get rid of 120 straight away. So think to yourself, if we have to keep them together, how can we do that? So, for example, if we put the 2 dictionaries together, can we have the novels like this? Yes or no? Once you've decided how they go together, you can figure out how many ways there are in that order. So, for example, if we had DD, N, how many ways can we organize those 2 dictionaries, and how many ways can we organize those 3 novels? Now, for our algebra and functions question, Tobin's chosen a really interesting one here because there's 2 quite different approaches. So one approach is going to be very algebraic, and we're going to sort of say, well, what do we know about these set of positive integers relating to the mean? Of course, if you want the mean of a set of numbers, you're going to have to add them all together. So this is actually a sum of an arithmetic series. So this 1 to n, we've got an arithmetic series from 1 to n. So think about how you're going to sum those n digits. You're going to then remove one of the numbers. So let's just call that x. It's not necessarily going to be n. We don't know it's the largest number. And that's going to be equal to 4.75, which is, by the way, 19 over 4 times the number of numbers left, because we know that when we subtract x, if the mean is 4.75, that means the total is 4.75 times n minus 1. Now, this is a Diophantine equation, and it's really useful actually to know about Diophantine equations because they are equations where you've got more than one unknown and only one equation, but you can solve them because of the limitations on the values of x, in this case, x and n. So we're only allowing positive integers for x and n here. So you could rearrange that a bit. Obviously, you have to substitute an expression in for Sn, and then you can think about different values of x. And this is another one of those questions where it's worth reminding yourself one of these values has to be correct. So you can do a bit of trial and elimination. Now, an alternative approach, which Tobin suggested, which I think is a great way to do it, is to say, well, hang on, how would you end up with a set of numbers having a mean of 4.75, i.e. 19 over 4? Well, actually, that means that the sum of the numbers, if there were 4 numbers, their sum would have to be 19. And we know it's going to have to be a multiple of 4 numbers in order to get this 19 over 4 as the mean. If there were 8 numbers, the mean would be 38. If there were 12 numbers, the mean would be 57. And we can work on this basis to say, well, if it was 12 numbers, then that means we would have been summing 1 to 13. What is the sum of 1 to 13? Is there a way we can remove one of those numbers from the sum and end up with 57? Or if we had 8 numbers with a mean of 4.75, that means that we would have had 9 numbers in the original list, and you can do this just purely numerically. Now, our next question here is our geometry and functions. And here we've got an element of circles, and there is going to be some similar triangles in here as well. So this is a very common style of TMUA question. And what we can see is, and what I always recommend, is that if you ever have a circle, it's always worth drawing in radii to points of interest on the circumference. Now here, The points of interest on the circumference, and this is usually the case, are tangents to the circle, or where a circle touches another circle. We also know that when two circles touch, the straight line between the two centers, well, there is a straight line between the two centers that passes through the point which they touch. We also know, because this is a tangent, this is a right angle, and we can extend this here to get 30 degrees. And then we can also use the fact that we've got similar triangles. Here, that triangle is going to be similar to that triangle. And because it's got a side length of 3, we know that's 1.5. That should give you enough information to then start finding the radii. So again, the sort of takeaway here is to start drawing radii that are useful on the circle, and because it's equilateral, remember, every bit of information is going to be useful. We know that we've got those 60-degree angles in there. Now, this is a good question for our logic question, because it uses a very common theme in TMUA, which is the disproof by counterexample. Now, one of the things that you really need to practice in order to be successful at TMUA is the idea of labeling an event A and labeling an event B. So here we're saying n being prime, we could call that event A. So n is a prime number, that's event A. And then B is that exactly one of, and that word exactly one is going to be important. Again, details always matter. So exactly one of these two is prime, and that's going to be our event B. So the statement is an if-then statement. So it's if A, then B, which means that A being true implies B being true. So a counterexample to this, we require A being true, and that's what students sometimes forget. Not only do we need statement B to not be true, but we do need A to be true. So we need A to be true and B not true. So which one of those is going to give us A true and B not true? And again, I'm going to draw your attention to that notation of, that statement of exactly one. What is the converse of exactly one? Really think about that. Thank you. I hope this was helpful.